The last part of section 2.1 is to talk about x and y intercepts. Keep in mind that x and y intercepts are just the points where our graph of our function crosses the x or y axis. So we might have just one x-intercept and one y-intercept. We might have a couple. We might have three. It kind of just depends on our function. So for this particular circle, it looks as though my circle touches the y-axis at 3 and touches the x-axis at 3. So my x-intercept would be 3, 0, and my y-intercept would be 0, 3. And again, pay attention in ALEKS, they might not make you write it as an ordered pair, which is fine, so you would just say your x-intercept is 3 and your y-intercept is 3. So let's look at another. Notice here I don't have a graph to be able to cheat with, so let's talk about how to do it without a graph. Obviously I could just get my graphing calculator out or go to desmos.com and graph it, but let's talk about how to do it mathematically, since it's a math class and all. If I want to find the x-intercept, and again there could be more than one, I have to set y equal to 0. So here I would say 0 equals x squared plus 5. I would say negative 5 equals x squared. And I can see right away that I can't square something and get a negative 5. But let's say I didn't see that because I'm just like, doing math and I'm not paying attention to whether it makes sense. So if I took the square root of negative 5, I would get plus or minus, and it's a negative, so it would be I radical 5, which is an imaginary number. Now when you get an imaginary number, is it possible that it crosses the x-axis? No, so we would say none. And again, if I were to explain it, which you would want to do on an assessment, you would say because it's an imaginary number. And for the y-intercept, which typically there's only one of those if it's a y equals equation, I'm going to set x equal to 0. So this one's the easier one. Y equals 0 squared plus 5, y equals 0 plus 5, or just 5, which means my y-intercept is 5, or again 0, 5, depending on the format they want it in. This one's not so fun. Again, feel free to graph it so that you know what you're looking at. But we're just going to do the math here, same thing that we did before. So I'm going to start with my x-intercept. And on my x-intercept, I set y equal to 0. So I'm going to say x squared over 9 plus 0 plus 3 squared divided by 4 equals 1. And of course, this one's not going to be super fun. X squared over 9, 0 plus 3 is 3, 3 squared is 9. I'm going to try to get that x by itself because I don't like what's happening right now. And so to get the x by itself, I'm going to subtract 9/4 from each side. Now 9/4 is a nice decimal. If you want to turn it into 2.25, you certainly can. That would give me x squared over 9 equals 1 minus 2.25, which is 1.25 or 5/4. Then I would multiply each side by 9, and that would get rid of the 9 in my denominator and give me 45/4. And then of course I would take the square root of each side, and that gives me plus or minus, so it looks like I'm going to have two intercepts on this one. The square root of 45, not a whole number, but I can take a 9 out. Radical 9, radical 5, so 3 radical 5 over 4 square root is 2. So plus or minus 3 radical 5 over 2. And I'm not going to write those as ordered pairs, I'm just going to write it just like that. For my y-intercept, hopefully it's not quite as much work, but let's just dive in and see. For the y-intercept, I'm going to set x equal to 0. So I'm going to end up with 0 squared over 9 plus y plus 3 quantity squared over 4 equals 1. This essentially goes away because it's 0 over 9, which is 0. So I'm going to multiply each side by 4. That gives me y plus 3 quantity squared equals 4. Then I'm going to take the square root of each side. That gives me, and I'm going to write it over here because I'm running out of room, so y plus 3, when I took the square root, it just got rid of, or sorry, when I took the square root, it got rid of the squared. And then the square root of 4 is plus or minus 2. So now to solve, I'm going to say y plus 3 equals 2, and y plus 3 equals negative 2, which gives me y equals negative 1 and y equals negative 5. So I end up with 2 x-intercepts and 2 y-intercepts. And you might be saying, well, that doesn't make any sense. But if you graph it, you can see that it does in fact make sense because we're not dealing with a straight line or a parabola. So it's okay that it crosses each axis more than once. Last one for you to try on your own, so press pause, try this question, and then press play to see how you did. Keep in mind this is a parabola because we've got a y equals x squared situation, so the most number of times it can cross the x is 2, and the most number of times it can cross the y is 1, but it might not cross even that many times. So do the math and then press play to see how you did. So again, first I'm going to set y equal to 0. So 0 equals x squared minus 1. Add 1 to each side, or I could have factored at that point. I'm going to go ahead and use that square root property. To get plus or minus 1 equals x, so I do in fact have 2 x-intercepts, one at 1 and one at negative 1. For the y-intercept, I get y equals 0 squared minus 1, or y equals 0 minus 1, which is y equals negative 1. So 1 y-intercept and 2 x-intercepts.